All right, now, question?
How do you get to
4B?
5?
Pardon?
Where'd the fifth one come from on the column?
Fifth?
The fifth one.
Oh, it's this number.
Oh, okay.
It's this number. So whenever you do what's called an augmented matrix, the idea is that this side over here, all your first variables are lined up, all your second variables are lined up, third variable, fourth variable, fifth. So you can't have like A here and then A here and C here. All your A's need to be lined up, all your B's, all your C's, all your D's, all your equals, all a number. If you do that and convert it over there, it's called an augmented matrix. So this matrix basically is just another short way. It's like a short, condensed way of writing that. So this is just, hey, this is all the coefficients on your A's. This is the coefficients on your B's, your C's, your D's, and then equals, and then over here, these are just numbers, right? So there's a method called Gaussian elimination that you learn in college algebra. Elimination, you have substitution and elimination for solving systems of equations. And there's a way that we can use elimination and we can actually solve this system, but it's a pain in the ass to do by hand. Our calculators will do it for us. We just have to figure out how to properly type this into our calculator, right? Which is why I asked you to bring your calculators. So, little disclaimer, I realize some of you already know how to input that as a matrix into your calculator, and if you do, great, that's wonderful. I'm going to show a method that should work on every TI calculator regardless of the model. Because as the models change, they change the user interface and things are a little different. So what I'm going to do is I'm going to have us all go and pull up a core routine out of the brains, the operating system. We're going to pull up a routine and we're going to execute that routine. So the syntax is going to be weird, especially if you know how to put a matrix in your calculator. This is going to look different. So don't at the end say, hey, but can I do this? I'll say, yes, you can do that. You know, this again is more for like trying to cover everybody's calculator, all right? All right, so I need a way to plug this in. And I want us to think a little abstractly about what if there was a way, right? What if there was a way that I could somehow turn this matrix into this matrix, where I have 1, 0, 0, 0, and then a number, and then 0, 1, 0, 0, then a number, then 0, 0, 1, 0, then a number, and then 0, 0, 0, 1, and then a number. If I had this, right, if I had this, what would this represent? This is, remember, this is our A's, our B's, our C's, our D's, our numbers. What would this first, this would tell me that A equals that number, right? And this would tell me that what? B is that number. This one would be C is that number. And then this would mean D is that number. Do y'all agree? Yeah. If there was somehow a way that I could turn this into that, then this list of numbers down here would be my answers, A, B, C, and D respectively. Exactly. And there's a good thing. In your calculator, there is an algorithm that actually does that. It'll take a matrix and it'll do all the steps of elimination that we hate doing, right? It'll do it for you, and it'll convert this into this. This matrix right here is what we say is in, anyone who does linear algebra at some point, we call that reduced row echelon form. That's the way the matrix looks. Reduced row echelon form. Okay, don't worry about it. But that's the routine we're going to call from the computer, from the calculator. We're going to call the reduced row echelon form function. So, in your notes that are online, I go through this whole process, okay? I give you an example of a system of equations. I show you how to do the augmented matrix, and I actually show you keystroke for keystroke how to type in the augmented matrix into the calculator, and then what the calculator should give you back at the end. All right? Now, I want to do that for this problem, but just know you have notes on this as well. So first thing we need to do is we need to call up the routine that allows you to actually do that. So on your calculators, this is where there's a little bit of difference. Some of you actually have a matrix menu. There's a menu on your calculator that actually there's a button somewhere, or you might have to hit shift or something, that it says matrix. Yes? Yeah. Do you see it? Okay, does anyone not see matrix? If you don't, raise your hand, I'll come show you. Everyone has the matrix key?
You usually have to press the second
Yes?
button.
You might, on some you do, some you don't, right? So we're good? So when you hit that, it should bring you to another menu. And up on the top, you should have the option of doing math now, right? So from there, you should have an option for math. And then it should list all these functions. And you want to scroll down until you get to the one that says RREF. Not REF, RREF, because there's a difference between the two. RREF. If it's just REF, that's called reduced echelon form, which is a little different than reduced row echelon form. Slight little difference.
Is it okay if I write the navigation path?
Nope.
And where do you
Nope.
find
You need to learn how to do it on your calculator. If you want to use it, right? If you want to use this technique on the test, then just learn it. Once you do it, it's not that bad. Like I think you pick it up pretty quick. Okay, ready? Now, hit enter, and now what you should be is back at the home screen, and you should see RREF with a parenthesis, and it should be flashing, waiting for you to put the information in. So now what I need to do is I need to feed the computer the matrix. And this syntax is very important. You have to get this exactly right. So the first thing I'm going to type in is a bracket. And I believe the bracket's above the 7. Let me check. Above the multiplication. Okay, yeah, it's not a curly bracket. Okay? That's your first keystroke. Okay? What that tells the calculator is, okay, I'm about to start the matrix. Okay? Here it comes. Now another bracket. That tells the calculator, here comes the first row of numbers. Now in my notes that are online, I actually explain this, right? Starting the matrix, starting the first row, okay? Okay, so now what I do is I actually type in the first row of numbers with commas between the numbers. So I'll do 1, 0, 1, 0, 0. I type in those numbers. Yeah, commas above the 7 on most of your calculators.
This app has like a graphing calculator on it, but only the Pro version lets you use more than 2 rows in the matrix.
Well, you can't use that. Make sure that you get a graphing calculator for the test.
I just left it at home.
Okay. Now I close the bracket. That tells the computer, okay, that's it. I'm done with the first row. Now, no commas. Bracket again, open bracket, starts the second row. And you get 4, 1, 2, 1, 2 with commas between them. Are you getting the idea here? Close the bracket, open the next third row. 4, 4, 0, 0, 4. Close bracket. Above the 7, I believe.
Yeah, it's right there. It's its own.
And then open bracket, last row, 0, 4, 0, 0, 4. Close bracket. Yes?
If you don't got bracket,
You have brackets.
okay?
Nope. You have brackets. Look at the multiplication and division symbols. Do you see it like you have to hit shift? Oh, well, it's got to be the graphing calculator. Were you here last time?
No.
Okay, so last time what I said was that if you don't have a graphing calculator to bring today, then look into checking one out from the tutoring lab because they'll loan it to you for the semester. It just might take a little while for them to get it to you. There's a process for it. So just go across the hall here to 308 and they'll help you out. It's not going to work on there. That calculator is not capable of doing this. We good? I closed the last one here. That closed out the row, right? I need another close. That closes out the matrix. right? Remember, the first bracket was start the matrix, start the first row, end the first row, start the second row, end the second row, start the third row, end the third row, start the fourth row, end the fourth row, end the matrix, parenthesis, close the function, close the RREF, and then hit enter. And when you hit enter, it should spit out something like this. And you should be able to look down the right-hand side and see your answers. Do y'all see them? What are they?
0, 1, 0, 1.
What do you get? 0, 1, 0, 1.
Oh, yeah.
And then, of course, you'll have like 1, 0, 0, 0, and then you'll have 0, 1, 0, 0, and then you'll have 0, 0, 1, 0, and then you'll have 0, 0, 0, 1.
So the last column.
This last column are your answers.
So if you type in a wrong number, it'll give you results.
If you type in what?
A wrong, if you accidentally
Oh, yeah, for
don't
sure.
do type in the correct numbers, it'll still give you an answer.
It'll still give you,
Like if I type in a 3 instead of a 4, it's still going to give me an answer.
an answer. Oh, I thought you said it'll still give you the right answer. I said, no, it'll still give you an answer. Oh, yeah, it'll give you an answer. It just won't be right. Yeah, so there's some potential here for some what do they call that? User error. Yeah, syntax.
Is there an easy way to take the final? I mean, you can look at the final matrix and see, but is there like an easy check to take that and make it equal to something?
Well, it should solve all the equations, right?
Yeah.
So you had 4 equations, didn't you? You could take those answers and plug them into each of the equations, and you should have true statements. Yeah.
That's how you check.
But if you're taking a test with me, I would expect to see nice numbers. Like nice meaning like if you see something like 0.3659, you know, I'm going to keep the numbers nice, right? All right, so we're almost to the point of being able to finish the problem. Remember, we were breaking this down, so now we can do integral. It was, I'm just going to recap here, it was a over x, it was b over x squared, it was c over x plus 2, and then d over x plus 2 squared, right? That's what we were trying to break down. We just figured out that we just figured out what a, b, c, and d were, right? A was what? 0, so this is gone. C was 0 as well, right?
Yeah.
That's gone. And so all we had was b, which was 1 over x squared. And then we had plus d, which was 1 as well, right?
Yep.
Over x plus 2 squared.
Nice.
Yeah, it worked out nice. Going off your answers on your computer. Did anyone have any question on the calculator? Was everyone able to do that? Yeah?
It's on your notes, right? How do you find your notes?
What?
How do you find your notes online? I know it's a simple question.
This is exactly what I'm talking about.
I know, I'm sorry.
Okay? I've provided them. I've given guidance from day one where they are.
Okay.
Okay? I mean,
I'll,
they're under files,
I'll look
course
for
files, right?
files.
But your question was, is this there?
Yeah,
Is
no,
what there?
No, sorry. My question is, was not, is this there? My question was, where can I find the files, which is on the Files tab in Canada.
You're talking about, no, you're talking about the one that I had the sample of how to type it into your calculator?
Yes.
That's under Files, Formula Sheets.
Gotcha.
Yes.
All right, thank you.
What? You just answered your own question, didn't you?
Well, I just,
Okay. What you asked me, I said you can't do.
yes.
Okay. All right. Can we find the antiderivative of this? I hope so. We've come this far, right? This is just, I mean, that's the same as x to the negative 2, right? So you could do the integral of that. And then that one is basically the same thing, but little u sub before it, right?
Yeah.
So I'm just going to get to the final answer. We've got negative x to the negative 1 should be the antiderivative of that. And then that one should be negative x plus 2 to the negative 1, and then plus some constant. That's your antiderivative.
I had it printed out.
I know. What? But yeah, but no, don't. You asked me
I know.
if you could write this down on your other sheet, and I said you can't do that. All right. So now on the test, there was more to this problem on the actual exam, because if you look, they had a number here, 1, and they had infinity here, and then there was more they had to do. But that gives you an idea. I've given you 2 problems that are partial fractions that I put on other tests. Yes?
That's where we do what we did very in the last semester, right? Where you do that straight line, throw the numbers in there, and
Yes, but infinity makes it a little problematic.
Okay.
That's a little problem. I mean, we just have to figure out what does that mean, and then how do we deal with that. But yes?
When we see those like above and below the integrand, like on the homework and stuff, up until the point we just ignore that, right?
Yes, that's right.
Okay.
All right, we have 20 minutes, 18 minutes, not enough time to really start the next section. I figure at this point, why don't we're all in on this section, so this is another problem off this test.
I have a quick question.
Yep.
So, when the powers are the same, we went like in long division.
We went through long division.
Can you not pull out an X and then do integration by part to kind of pop it loose and then just work with the new integral?
I suppose you could. I mean, are you saying that you would let your u be the x and then your dv be the other part,
Yeah.
and then, yeah?
And then it would just leave you with something easier to work with.
Maybe. I don't know. I don't know if there was, the x would go away, but that new integral would be, I'm not quite sure it would be any easier than, I mean, I don't know. You could, yeah, I don't know. Okay, you got this problem written down? I was trying to explain to my Cal 1 students today, we were covering chain rule. I was trying to explain to them that as challenging as it may seem initially, the chain rule, that eventually you do get to a point where you understand it's kind of just this process you run through, right? And I said how in Cal 2, there's not as much of this process, and like every problem is its own unique sort of situation. We try to, like, so in Cal 1, we give them like rules of thumb, right? That when you see a product, you apply the product rule. When you see the quotient, you apply the quotient rule. Here, it's like, if I could give you like, every time you see this, do this, then I would do that, but it just doesn't, it's just not that straightforward. Everything is, you have to analyze, understand, adapt to the question.
It's like a list of stuff you go through.
There's a bunch. Techniques, that's why this is called techniques of integration. It's a technique, right? It's not a rule. It's not power rule, quotient rule, chain rule. It's techniques.
They're tools.
Exactly, they're tools. There's a lot of ways to chop a tree down. Okay, here we go. So I'm looking at this, and I see a linear over a quadratic. So I'm going to first check, can I factor the quadratic? That's not reducible, so you can check, this doesn't factor. So I'm not going to be able to split this up and do like A over the first factor, B over the second factor. Can't do that. So what else? Check real quick for basic U sub. I don't think basic U sub would work, right? No. So what is the method that I shared with you when you have this situation, linear over irreducible quadratic? How did I show you? I forced it to happen. This is the one where I force it to happen. So I'm going to go through that, all right? Yes?
I have a question. It's
Uh-huh.
gonna be like a dumb question, but I know like there's a lot of like the different types of scenarios, like this one.
Yeah.
Or get like a constant over just
Yeah, yeah.
The steps that we take for each one, is that just something that we just have to memorize, or is there gonna be like a
Don't look at it like memorization.
Okay.
Look at it like, I don't know.
Oh, but
What do you like to do?
I do have a question.
Do you have a hobby?
Would it be easier?
Do you know what I'm saying? Like if, it's kind of like you don't really have to, if you like really like to go running or lifting weights or something, you don't have to remember a list of instructions on how to get ready for that, right? Like, so you want to look at this more like, I don't know, you just get to a comfort level with it where you're not thinking so much of it as like, I memorized the formula. It's, I don't know, just seeing that, it's so hard to explain, you know? I mean, this is the challenge of it, is that if you try and make this a memorization thing, it's gonna be really tough because it's too much to try and remember. But if you do enough problems, I promise, it starts to come. You start to see it without having to think too much about it.
So if I'm like dumbbell pressing some stuff, I should try and do some classes.
Yeah, that's right. So if you lift weights, make sure you're looking at your calculus book at the same time.
So what if it really is like slightly easier to like memorize the table of integrals? Like, what if it is?
Then go for it. If you have that sort of memory, then go for it. But I can tell you that the table of integrals is limited. It doesn't cover everything.
Yeah.
Right.
But it's just a lot easier to do all the work if you got the tools in your belt, you know?
Yeah, but how many people can do that? Right?
And tool belt. I don't know.
So I'm going to let the denominator be u. Even though I know a u substitution doesn't work like initially, the method for linear over irreducible quadratic, at least the way I like to do it, is to make this substitution, figure out what du is, right? Check to make sure these don't match. They don't, right? And then force that to look like that.
So you factor a 2 and then...
I'm not even going to touch that. I'm just going to leave it as is, and I'm going to make that turn into that. Okay, 2 over 2. I'm going to start. So you always start with the x. I want to make that x become 2x. So I take this integral, I multiply on the outside 2 over 2. This is x minus 1 over x squared plus 6x plus 25 dx. And then I force the 2 up top inside. And I leave the 2 on the bottom where it is, so that leaves me a 1/2 out here, 2x minus 2 over the x squared plus 6x plus 25 dx. I told you when I first showed you this for the first time that if you go to a tutor or something like that, they're probably going to show you something else. And all I said about it was that I believe that this thing I'm doing here is a little, like, it's my opinion. I just think that this is just kind of a better way of thinking than just following like, okay, when you see this, complete the square. You know, it's more of like, hey, I'm going to try and make, because a lot of times, like in the real world, you're not going to be doing this, but you might be working on a problem, and sometimes you just have to kind of like think outside the box and try something different, right? Instead of like, hey, where's the manual on how to cover, you know, like, you don't want to be that type of person. You want to be the problem solver. Hold on. Let me keep going. All right, here we go. I'm almost there. I have 2x minus 2. I don't have 2x plus 6, right? So I'm going to add a 0, right? A hidden 0 right here, which again I think is a more advanced sort of idea. Is that I realize there's a plus 0 here. So I do plus 6 minus 6. Why do I do plus 6? Because I want plus 6, right? Why do I do minus 6? Because it has to be a 0, right? So that right there I'm just introducing to the problem. And then I still had minus 2 up top. And then over x squared plus 6x plus 25 dx equals 1/2. Okay, now I'm going to split this up. This becomes 2x plus 6 over x squared plus 6x plus 25 dx minus 8. I might be going further than I should here. But this is not the first time I've done one of these. Yes, 1/2. Hold on. This will be a 4. Thank you. I messed that up. There. So all I did here was I split it here, and I'm going to put this over this. Why? That, like this, would be 1 over u du. Right? The derivative of this is up here. So if I look at that by itself, that's an integral I can handle and I'm happy to see. What I'm still left with, though, is this. Oh my gosh. This over this, right? And that's -8.
Yeah.
And then I can pull -8 out, divide it by 2, and that's where the -4 comes from. Do y'all see how I broke this up? Yes? Yes? I'm not done, but yes? Bless you.
Could you re-explain the step of adding the 0, the in sixes? Or adding the +6, -6?
Well, do you agree that's 0?
Yeah, yeah.
And do you agree that adding 0 to anything doesn't change it?
Yeah, no, I understand
Okay.
how it works. Just what's the method that brought us to do that?
Why +6?
Yeah.
Because I'm trying to get it to look like this. Right? Because the original thing was, this is what would happen if I let u be the denominator. I would really love to see this appear somewhere. But that's what I have. I want that to look like 2x plus 6. So first I make it a 2x. And then I just need a +6 here. So I make it a +6 minus 6, and then I still have the -2.
I get it.
Oh, shit. Okay. Thank you. Appreciate it. We're almost there. Oh my gosh. I'm going up with this. 1/2. Okay, this right here is just a basic U sub, right?
Yeah.
By design. I'm going to crawl across the finish line here. Okay. Okay, that's this one, right? I'm sorry, I'm sneezing over here. And what about the other one?
So it's a constant over irreducible quadratic, right?
It's a constant over an irreducible quadratic, right? Constant over irreducible. For that one, we complete the square. When it's linear over irreducible quadratic, we do this. And what that happens at the end is you should get a constant over an irreducible quadratic. So I'm going to go look at that integral right there. I'm just going to carry it over here. Are there any questions on how I got from here to here? Everyone's good? Basic U sub, U is the bottom, du is the top. 1 over u du, natural log. Yes?
So for the exam, do we have to show work?
For this to here?
Yeah.
No. On the exam, I would want you to know the whole reason you did this is because you know it's going to become that, right? So you don't need to show the work. Now, I mean, you have to show all the work getting to this, but yeah, that step, no. Okay, so this one, I'm going to take this, and I've got the x squared plus 6x plus 25. And now I have to complete the square in the denominator. So complete the square down here. Let me do it right here. If I complete the square, how do we complete the square? We take half of that, which is 3 squared, which is 9, add it and subtract it. So I forgot about x. 6x plus 9 minus 9? Plus 9 minus 9?
Yes.
And then another hidden 0, plus 25. So that's just me rewriting that. There's my hidden 0. This guarantees to factor. Perfect square trinomial. So it factors to be x plus 3 squared. And then these two together give me
16.
plus 16.
I have a little tip. With the completing of the square.
A tip? Is that what you said?
Yeah.
Oh, okay, good.
Do you know the formula is b over 2 squared
The formula what?
for completing the square? It's b over 2 and then that square. Well,
The b over 2 is always the thing that is inside the parentheses?
yeah.
Yeah, I think I said that to you.
Oh,
No?
okay.
But I did a little different. I called, what I said is, when you go to factor, like let's say this one right here, and that is a tip, that is always true. If we go to do this 25 here, that was this, then whatever number is here, right, that's the b, you first divide it by 2. I call that the first magic number, okay? And then you square it, and that's 9, and that's your second magic number. So what you do now is you get to here, you add and subtract your second magic number, and then this will guarantee to be this, and then this will always be your first magic number, and then that thing squared. So that is correct. Let's finish this up. I only have a couple of minutes. We're almost there. I have this integral equals -4, and then 1 over, okay, the bottom we factored, different square, sorry. Completing the square, right? So we completed the square in the denominator. And the whole point of that is because once we do that, what? It's been there for a while. Well, yeah, but I had a 1/2 in front of the whole thing. And I had forgotten that myself. Someone said -4. Yeah, this 1/2, this, when they split up, it comes with us. Okay, why are we getting into that? Formula 17. Now, it could turn out that this is a minus. It could be. It depends on how the numbers work out for us. So it's either going to be here formula 17 or 19 or 20, I believe, depending on how things are ordered. But in this particular case, this is formula 17. And it's very important that we realize that this right here is linear, or else we can't use formula 17. That's linear, so we should just go straight to it. We get -4 times, okay, formula 17 says 1 over A for us here is 4, times inverse tangent of x plus 3 over A, or 4. There we go. And then plus C. Tack that on to the rest of our answer, and we're done. All right, so, wow. We've been going over my old test. There were 5 problems on that test. And we did 3 of them today, right? Yeah, so, I mean, obviously it takes time, right? I mean, these problems take time. And this is me doing the problem, so it's going to be a little faster. So I can only give you so many problems on the test. But the problem with this is that if you get to one of them and you completely blank out, it's going to be hard to pass the exam, which means that you need to practice, 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 study, ask questions, right? Watch the videos if you need to. All right, we good?
Is the rest of that exam online?
No. The rest, numbers 1 and 2, are a mystery. All right, everyone. Y'all have a good weekend, right? Have a good weekend.